Good morning to all. Today we are going to see about FSK modulation and demodulation experiment, and here we have the clock generator, data generator. After this, here also we have data generator, 4 options. We can take any one data, FSK modulator and FSK demodulator. So in this we can check the data, then we will check the clock signal, note down the amplitude and time period of the clock, then go for the data. So what is our data, how many number of ones, how many number of zeros are there, that we can compare with the clock and we need to note down. Then connect this one as input here, then observe the FSK modulator, then give this output as input to demodulator, then observe the output here, and this data and this data, this output should be matched. This is the FSK output. So now we will connect the circuit. Just connected positive here, negative is connected here, this is connected to channel 1. Now I am going to switch on the kit. So now we are getting, but we need to adjust this time per division, and it is channel 1. So this is the clock signal. We need to note down the amplitude and time period of this clock signal. Next, I am just removing this connection and I am placing here. Next, I need to check for the data, whether it is coming or not. See, we are getting the data also, but we need to adjust how many number of ones, how many number of zeros we are getting here. So this is our data. In this, how many number of ones, how many number of zeros, how to decide means we need to compare with the clock. So connected the clock in channel 2, channel 1 data is there, channel 2 clock is there. Now we need to put this one in dual mode. We need to get how many number of clock signals are there for clock cycle, or already we have noted down the time period of the clock now. So this time period divided by this time period, you will get how many number of ones are there, and this time period divided by clock time period will decide how many number of zeros. Likewise also we can find out. Why? Because this is the high frequency signal, this is the low frequency signal, that's why we are getting like this. So don't worry. So what is the time period of the clock? That already noted. Now what is the time period of these ones, what is the time period of these zeros? Now the time period of these ones divided by clock time period, the time period of these zeros divided by clock time period will give number of ones and number of zeros. Like that also we can find out. Okay. So likewise we can find the data. Now here I am taking the first data. We can change this data option. So I am changing this data to 2. So see here, we are getting like this data. If I change it to third pin, now the data is, so only zeros and somewhere we will get the ones. Okay, so that's why we can take either 1 or 0, which is visible to us, both zeros and ones. That's why you can take either first input or second input. Third, fourth also we are getting, but we are getting the more number of zeros, more number of ones. Okay. So after getting the data, we need to change. Now I am taking the clock output channel 2 to modulator. Then we need to connect the input also. Just connected the input. Data is channel 1, output is channel 2. I am going to switch on the kit. See, whenever we have the number of ones, there we need to get the high frequency signal. Whenever we have the zeros, there we need to get the low frequency signal. So according to this, for these many number of ones, excuse me, for these many number of ones, how many clock cycles we got? 1, 2, 3, 4, 5, 6, 7, 8. So for these many number of ones, I think we may get 16. 16 ones, 16 zeros. For 16 ones, we got 8 clock cycles, and for 16 zeros, we are getting the 2 clock cycles. Here 8 clock cycles, and here, see here, this is the output. Channel 2 is the output, channel 1 is the input. For these many number of ones, 16 ones, we are getting 8 clock cycles. For 16 zeros, we are getting the 2 clock cycles. So here, for 1, we need to get the high frequency signal. For 0, we need to get the low frequency signal. For 16 ones, we are getting 8 clock cycles. For 16 zeros, we are getting 2 clock cycles. So likewise, we need to draw for ones as well as zeros. If you draw these ones, these zeros, that is also enough. Okay, so this is the FSK output. FSK output. Now we need to connect this output as input here for the FSK demodulator. I am switching off this one. Okay, before switch off this one. Next I am going to connect this one, channel 1 data as it is, and channel 2 I am connecting the FSK demodulator. Now I need to give connection from here to here. So I am going to switch on this one. See, we got exactly. See, 2, 2. So this phase difference is there always from modulator to demodulator, but we need to notice whether the amplitude and time period is exactly matching or not. Okay, that we need to observe. See here, this is the FSK demodulator. Sometimes we need to adjust these knobs also. Here we are getting directly, but sometimes if any disturbance is there, that we need to tune with the help of these 2 knobs. Okay, we need to adjust these 2 knobs. If I am adjusting this one, see, this one is gone. By adjusting this one is gone. If I am increasing this one, see here, we are getting. Okay, likewise we need to tune to get the demodulation. This is about the FSK modulator and demodulator, and these are the connections we need to give finally. If it is useful, you are feeling, please like the video. Thank you so much for watching.